So, you want to know how this turned into this? Let me show you. In the grand biological race to become faster, stronger, and bigger, most animals followed a predictable path. They added features: more armor, bigger wings, or longer legs. But roughly 150 million years ago, a small group of lizards began a journey defined not by what they could grow, but by what they could throw away. Today, snakes are a global powerhouse. Nearly 4,000 species have conquered every environment, from the sun-scorched dunes of the Sahara to the high-altitude forests of the Himalayas. They are the ultimate specialists in minimalism. But to understand how these living tubes became the most successful predators on Earth, we have to look past the scales and venom. We have to go back to a time when the world was ruled by giants, and the ancestors of the cobra were just tiny four-legged shadows scurrying through the dirt. Chapter 1. The Great Lizard Divorce. Our story doesn't actually begin with a snake. It begins with the squamata, the massive order of scaled reptiles that includes lizards. During the Middle Jurassic, the lizard family tree began to splinter. While some lizards were evolving into the massive, sail-backed predators we see in paleoart, one lineage took a different path. These were likely small, secretive hunters belonging to a group known as the Titanoboa. Contrary to the popular image of a snake simply deciding to stop walking, this was a high-stakes ecological gamble. These proto-snakes were likely subterranean or heavy-cover specialists. In the cramped, high-pressure world of root systems and leaf litter, legs aren't just unnecessary, they are an obstacle. Nature began to favor the elongation gene. Over millions of years, their vertebrae multiplied like a repeating architectural motif, while their limbs began to shrink, tucked away to reduce friction. They weren't becoming lesser lizards, they were becoming a new kind of biological engine. Chapter 2. The Missing Links, Najash and Tetrapodophis. The fossil record was once a frustratingly blank page regarding this transition, but recent discoveries have filled in the gaps with startling detail. Enter Najash rionegrina. Found in the arid landscapes of Patagonia, this 90-million-year-old creature is the Archaeopteryx of snakes. Najash was a ground dweller that possessed a robust two-legged stance at its rear, complete with a pelvic girdle and a sacrum connecting its spine to its hips. It lived in a terrestrial environment, effectively debunking the old theory that snakes evolved primarily in the ocean. Najash proved that snakes learned to slither on land before they ever lost their legs. But the plot thickened with the discovery of Tetrapodophis amplectus in Brazil. Though its classification is still hotly debated by paleontologists, this creature represents a shocking four-legged snake phase. It possessed four tiny, delicate limbs that were likely useless for walking, but perfectly adapted for grasping prey or mates. It was a transitional masterpiece, a creature caught halfway between the world of the lizard and the world of the serpent. Chapter 3. The Asteroid and the Great Filter. 66 million years ago, the Age of Giants came to a fiery end. A 6-mile-wide asteroid slammed into the Yucatan Peninsula, triggering the KPG extinction event. The world's titans, the Triceratops, the T-Rex, and the massive long-necked sauropods, couldn't hide from the collapsing food chain. But the snakes could. Snakes possessed 3 survival cheats that allowed them to inherit the Earth. Metabolic thrift. A snake can go months between meals. When the sky went dark and the forests died, the high-energy dinosaurs starved. The snakes simply waited. Subterranean shelters. By living in burrows and under the soil, snakes were insulated from the immediate thermal pulse of the impact. The generalist diet. With their highly flexible skulls, snakes could eat almost anything that survived: small mammals, insects, or even the carcasses of the fallen. When the dust settled, only a few lineages of snakes remained, but the competition was gone. The world was an empty buffet. Chapter 4. The Rise of the Paleocene Titans. As the Earth warmed into the Paleocene hothouse, the planet became a global jungle. In this humid, high-oxygen environment, reptiles could reach sizes that seem like science fiction today. In the swampy rivers of what is now Colombia, a monster emerged, Titanoboa cerahonensis. At 43 feet long and weighing as much as a small car, Titanoboa was the apex predator of the post-dinosaur world. It didn't need venom. It followed the ancient path of constriction, using its immense mass to generate pressures that would literally stop the heart of its prey, often prehistoric crocodiles, in seconds. Titanoboa represents the peak of the Boyd, boa and python, body plan. But as the Earth began a long, slow cooling process 50 million years ago, these giants began to struggle. The tropical forests shrank, and a new world was born, the open grassland. Chapter 5. The Weaponization of Biology. The Age of Venom. The shift from dense jungles to open savannas changed the rules of hunting. In a jungle, you can ambush prey at close range. In a grassland, prey can see you coming from a mile away. To survive, snakes needed a long-distance solution. They didn't grow legs back to chase their prey. They evolved chemical warfare. The Colubridae and Elapidae families, cobras, kraits, and mambas, began to dominate. They developed specialized salivary glands that produced a cocktail of proteins designed to shut down the nervous system or dissolve tissue. This was the birth of the rapid strike. Instead of a long wrestling match of constriction, a viper could strike in a fraction of a second, inject its liquid death, and then simply follow the scent trail of the dying animal. This was more than just a hunting tactic. It was an energy-saving miracle. Venom allowed a small snake to take down a mammal 5 times its size without risking a physical fight. Chapter 6. A Sensory Revolution. As they lost their legs, snakes also lost their traditional way of seeing the world. Most snakes have poor eyesight compared to hawks or humans, but they developed a sensory suite that borders on the supernatural. The chemical GPS. The forked tongue is a marvel of engineering. By flicking it into the air, a snake gathers odor molecules. When the tongue retracted, it fits into the Jacobson's organ in the roof of the mouth. Because the tongue is forked, the snake can sense stereochemicals, knowing exactly which direction a prey animal turned, based on which fork of the tongue has a higher concentration of scent. Thermal vision. Pit vipers and some pythons developed pit organs, heat-sensing membranes that can detect a change in temperature of as little as 0.003 degrees Celsius. Even in total darkness, a rattlesnake sees a mouse as a glowing heat map. Seismic hearing. Snakes don't have external ears, but their jawbones are connected to their inner ear structures. They hear the world through vibrations in the ground. To a snake, the footsteps of a predator feel like a drumbeat. Chapter 7. The Ice, the Human, and the Future. The Pleistocene ice ages were the final test. As the glaciers marched south, snakes perfected brumation. Unlike true hibernation, brumation allows snakes to remain somewhat conscious, but with a metabolic rate near zero. They retreated into hibernacula, communal dens where hundreds of snakes would huddle together to share what little body heat they had. Today, snakes face a threat that no ice age or asteroid could match: the Anthropocene. Humanity has paved over the grasslands and leveled the rainforests. Invasive species like the mongoose in the Caribbean or feral cats in Australia have decimated local snake populations. Yet, the snake remains resilient. The common garter snake has adapted to suburban gardens. The monocled cobra has learned to hunt rats in the sewers of Bangkok. Conclusion: the enduring serpent. The evolution of the snake is a story of radical adaptation. They are a testament to the idea that you don't need limbs to be a master of your domain. They are the survivors of the great asteroid, the titans of the tropical swamps, and the chemists of the desert. We often fear what we don't understand, and the slithering, legless movement of a snake is so alien to our own that we have cast them as villains in our myths for millennia. But if you look closer, you see a creature of incredible elegance. A creature that spent 150 million years perfecting the art of less is more. From a tiny lizard in the Jurassic shadows to a global icon of survival, the snake is, and always has been, one of nature's most brilliant second acts. As they continue to adapt to our changing world, one thing is certain. Whether in a burrow, a tree, or the cracks of a city sidewalk, the serpent will find a way to thrive. If you enjoyed the video, like and subscribe for more.